Welcome to Home Learning. This is Ms. Fagwitsa taking you for mathematics. Today we're going to be doing trigonometry. Trigonometry, as we know it, we have three trigonometric ratios: the cosine, the tangent, and the sine. We all work on trigonometric ratios on right-angled triangles. Like, for instance, if I have a right-angled triangle, ABC, so this is triangle A, BC and C is a right angle. For angle A, so let's say this is our theta, the cosine ratio for A, the sine ratio for A, and the tangent ratio for A. We're going to do that. We know that if this is angle C, this is side C, this is side B, and this is side A. So cosine of theta is equals to adjacent over hypotenuse, and the adjacent here is B, hypotenuse is C. We know the hypotenuse is the longest side of the right angle triangle. And then sine theta is equals to opposite over hypotenuse. The opposite of angle theta is A, and the hypotenuse is C. And then the tangent of angle theta is equals to opposite over adjacent. And the opposite of angle theta is A, and the adjacent is B. So for tan you have A over B. But now we're going to be working on triangles that are not right-angled. How are we going to work on trigonometric ratios? Or how are we going to find angles and sides of triangles that are not right-angled? We're going to start with the sine formula, and then we'll move on to the cosine formula. We're going to draw a triangle which is not right-angled. And then from it, we'll see what we can do. Another thing we use for a right angled triangle is Pythagoras. We know that the square of the longest side, which is the hypotenuse, is equals to the square of one side plus the square of the other. So the square of the longest side is equals to the sum of the other squares. Now let's see what we can do if we have any other triangle other than a right angled triangle. Let's say this is triangle A, B, C, and you are only given, this is side A, this is side C, this is side B. Given any two angles, you can find the missing angle, because you know the sum of interior angles of a triangle is 180, right? So you add up what you have and subtract it from 180. So even the sides with that, in a right angle triangle, we use Pythagoras. But now, what are we going to do here? Let's see. We have this triangle as it is. We only know Pythagoras. We know that the trigonometric ratios we've used before. So the one thing we can do is we can cut this one such that we get a right angled triangle. So we draw a line from B. Now we have two right-angled triangles. We name this, say, F. So we have triangle BCF with triangle ABF. These are two right-angled triangles. So we can use that to find the other sides. If, say, you're given two sides given any two sides of this triangle, so you can find the missing side now using that. Let's see how we can do that one. First, let's start with this angle here. Let's say our theta is this one. What we have here, we have this full line. Line AB is full, as given. And then we have line AC. Line AC has been cut by our height. And then we have a new height, which is BF. Now, what are we going to use here? It is advisable to use what you have. We cannot use line AF, we do not know. But we now, given the angles, we know angle A, we know the side AB, which is side C. So we want to use the sine formula now. So we're going to have the sine of angle A is equals to opposite over hypotenuse. Our opposite is BF. Hypotenuse is line C. So we have BF over C, which means BF, we do not know BF, is equals to C sine A. So somehow we found the height, the new line we drawn on this triangle. Now we found it. Now that we know this one, we can also use the other side, angle C, because we know we have angle C, and when we have side BC, which is full. So now we can have the sine of angle C is equals to the same BF, which is the new height we created, over the new hypotenuse, which is A. So now we have sine BC is equals to BF over A. And then we make BF the subject of the formula. BF is equals to A sine C. BF is equals to A sine C. BF is equals to C sine A. This is the same BF, so we can use the same. Now we equate this to BF. We have BF is equals to C sine A. BF is equals to A sine C. So we have BF is equals to A sine C. We also have BF is equals to C sine A. Now we can eliminate BF on both, because we say these two are, if this is equals to BF and then the second one is equals to BF, that simply means that A sine C is equals to C sine A. As we are working on a non-right angled triangle, so we draw our own right angled triangle by drawing a line into this triangle, giving us two right angled triangles, and then we find the length of BF. We found that BF is equals to A sine C, and BF is also equals to C sine A, which means that A sine C is equals to C sine A. If I divide by A on both sides and by C on both sides, I will get that sine C is over C is equals to sine A over A. Now I have made myself a new trigonometric ratio using the sine. We'll also use, now we can find sine C given angle A, side A, and angle C, we can find sine C, or given angle C, side C, and angle A, we can find sine A. So with this ratio now we have four things. Given the three, you can find the one. What about side B? Now let's go back to our triangle and draw another line now from A. If we draw a line from angle A, it makes a right angle here. So now this will be our base. Now we're going to use, we'll have this angle here and this angle here. So we'll have angle C and angle B. Those are the full angles we have here. So we will use the full angles we're given as they are. We won't use this one we've halved. So now, because we don't know how much we've cut this one, probably more to the B or more to the C. So let's use the full one. The sine ratio, we are using sine now. The sine ratio of angle C, the sine ratio of angle B. We say the sine of B, it is the opposite of a hypotenuse. Sine of angle B, the opposite, this is, we name this one H, so we have a new height AH now. The opposite is AH, the hypotenuse is C. So now we have sine of angle B is AH over C. Sine of angle B is AH over C. We have a full angle C, we have a full side C, we have angle B. So which means AH, which we don't know, is side C multiplied by sine B. We go back to our diagram again. We use angle C now. The sine of C is the opposite AH over B. So which means now we have sine C is equals to AH over side B. Sine C is equals to AH. This is the capital letters AH. We have AH over B. So now we have two unknowns, AH and AH, the same thing, which means we have AH equals to C sine B. When we had AH up there being A sine C. So now if we equate AH again, we have the first AH and the second AH. We're going to join this to our ratio up there. We're going to get, now we have sine C over C is equals to sine A over A. Now we'll get that sine C over C is equals to sine B over B, which will add over here. Which means given any two angles and a side, or any two sides and the included angle, you can find the missing one. Now let's look at some examples. The sine ratio is sine A over A is equals to sine B over B equals to sine C over C. So given any angle, if it's not right angles, if it's right angled, you just use SOHCAHTOA. If it's not right angles, we use the sine formula. Let's look at some examples. Given an angle, say this is 80, this is 36.9, and this is 40 degrees. So we have A, B, C. This is not a right angle triangle, so we cannot use SOHCAHTOA. So we're going to use this one. We have sine A over A equals to sine B over B equals to sine C over C. Here we are given angle A, we are given angle B, we are given side B, which means you can find side A. So we're going to use sine A over A is equals to sine B over B. Angle A is 40 degrees, angle B is 80 degrees. So we're going to have sine of 40 degrees over A, we don't know, is equals to the sine of 80 degrees over 36.9. Now, we make our A the subject of the formula. We can multiply by A on both sides and calculate this and then divide by the sine 80 divided by 369 on the sine 40. An easier way of doing is, as we know that the ratio is sine A over A equals to sine B over B. This is the same as having A over sine A equals to B over sine B. So if you are looking for an unknown using the sine formula, it is advisable for you to have the one you are looking for on top. So it will be easier for you to eliminate and make it the subject of the formula. As we are looking for A here, our A is a denominator, which means that we have to multiply and divide. Whereas here, we simply have A on top. We substitute here, we substitute all the other side. We simply multiply by sine A, we are left with A. So depending on what is being asked from that question, you can use any of the two. It simply has the same mathematical value. Let's look at more examples of the sine formula, and then we're going to look at the cosine formula. We have a triangle which we have triangle ABC, with this angle B, we're not given. This is 6 centimeters, this is 4 centimeters, and then we have 30 degrees here. So angle A and side A you are given. Angle C you're not given, but you're given side C. You're supposed to find B. How can we do that? So now we'll start with what we have. We will start with the angle C because we do not have angle C. Once we have two angles in a triangle, you can simply find the third one using the sum of interior angles of a triangle, which is 180. So now we'll start with angle A and side A, angle C and side C. We have side C, which we do not have angle A. So we're going to have sine on top because we are looking for an angle. So we're going to have sine C over C is equals to sine A over side A. And then we substitute. Angle C we do not know. Side C is 4. Angle A is 30 degrees and side A is 6 degrees. We remember we're looking for B, which is we're looking for side B. We do not have angle B, so first we have to find angle B. How are we going to find angle B? We're going to use what we have. So we're going to use the sine formula to give us angle C, and then we use angle C to give us the missing angle in that triangle. Then using that angle, then we can find the side opposite that angle, which is side B. So now let's start by looking for angle C. Angle C, we have sine C is equals to side C, which is 4, equals to the sine of A, which is 30 degrees, over 6 centimeters, which means sine C is 4 sine 30 over 6. So sine C is equals to 4 sine 30 degrees over 6. This is the sine of C, not angle C. So make sure your calculators is always on degree mode when you are calculating the angles. So we're going to have sine 30. The sine of 30 is 0.5. Multiplied by 4, it will give you 2. And then 2, you divide the 2 by 6. Let me show all the working we said. We have 4 times 0.5, the sine of 30, over 6. 4 times 0.5 is going to give you 2. So you're going to have 2 over 6, which is the same as 1 over 3, which is 0.333. Now, this is the sine of C. We are looking for angle C. How are we going to find angle C? We're going to find with angle C is equals to the arcsine of 1 over 3. In your calculators, you punch second function sine and the 1 over 3, you're going to get the angle C, which is going to help us get angle B. We remember we're looking for angle B. Arcsine of 1 over 3 is 19.5, which means angle C is 19.5, which is equals to 19.5 degrees. That is angle C. Let's go back to our diagram. This is 19.5. So if this is 19.5, then we can find angle B. Angle B, we're going to use angle B to find side B, because the sine ratio is an angle with its opposing side. So now that we can find side angle B, then we can use it to find side B. We're looking for side B. Angle B is 180 minus the 30 plus the 19.5. As we know that the sum of interior angles of a triangle is 180, which means this is going to be 130.5 degrees. So if this is 130.5 degrees, we can find B using A side C and A and B or side A, we have everything now. The only thing missing is side B. So we're going to have sine B over B. But we're looking for B now. We said it's advisable for you to put the B on top, the one you're looking for on top. We're looking for angle C here, so we put sine C on top. But now we're looking for side B, so we're going to have B over sine B equals to probably side C over sine C or side A over sine A. It will all work. So side A over sine A. We have A, we've been given is 6. Angle A, we've been given is 30. So we substitute. We have B is equals B over the sine of 130 degrees 0.5 is equals to A is 6 over sine A over sine 30. So B, side B is equals to 6 times sine 130.5 over sine 30. So we have 6 times sine 130.5 degrees over the sine of A, which is the sine of 30 degrees. This will give you angle side B. So 6 times the sine of 130.5 divided by the sine of 30, which is 0.5, you get 9.12. 9.12 centimeters would be side B. Another thing, we have a triangle here. We'll say that the smallest triangle will give you the shortest angle, and the largest angle in a triangle will give you the longest side. So A is the small, we have A here, which is 8, it gives us 6 centimeters. C, the smallest, it's 19.5, it gives us 4 centimeters. And B, which is 130.5, it gave us 9.12, which is the longest side in the triangle. So the biggest angle, the side opposite the biggest angle is the longest side in that given triangle. Now we'll work on one more example on the sine formula. Given another triangle which is not right angle, because if it's right angle, we simply use SOHCAHTOA, which is sine is equals to opposite of hypotenuse, cosine is equals to adjacent of hypotenuse, and tangent is equals to opposite of adjacent. Now we have another one, A, B, C. You are given 100 degrees here for A. You are given 3 centimeters here. You're given 5 centimeters here. And then we have B centimeters, we don't know. And now we have to find all the unknown lengths and all the unknown angles. We have one angle here, which is 100. We need at least 2 angles for us to subtract from 180. So if we have 1, we can't help it. So we need to find an angle and then all the other sides. We know the sine formula. Then sine formula need an angle with its opposing side. We have 105 centimeters. A and side A, that one is complete. So we can use sine A over A or A over sine A equals to what? We have side C here. We do not have angle C, which means we can use that one. So you'll have sine C over side C is equals to sine A over side A. We substitute what we have. We do not have angle C, but we do have side C. We have angle A, we have side A. So let's substitute. Sine C over C, which is 3 centimeters, is equals to the sine of angle A, which is 100 degrees, over 5 centimeters, which is side A. We are looking for sine C. One thing we do not have is angle C. We'll start by finding angle C. So we'll have sine C is equals to 3 sine 100. We are multiplying by 3 on both sides. By 3 here. These 3 will cancel this 3 this side, leaving sine C on its own. So 3 times sine 100 is 2.95. So sine C is equals to 2.95. 2.95 is the sine of angle C. So what is angle C? Means angle C is the arcsine of 2.95. So we have arcsine of 2.95. Oh, sorry, we didn't divide by 5. We're supposed to divide by 5 here. This 5 here, it's 2.95 divided by 5. We still have the 5 here. So we have, so sine C is equals to 0.59, which means C is equals to the arcsine of 0.59, which means angle C is 36.2 degrees. Now we have angle C. This one is 36.2 degrees. And our triangle now has 2 angles. We need 1 angle. So we'll add the 2 and subtract the sum from 180, which is the sum of all interior angles. So 100 plus 36.2, all subtracted from 180, we get 43.8. Now we have angle B. Inside B, we can use that to calculate the missing side, side B. We have all the angles now. We can use sine C over side C equals to sine B over side B, or we can use sine A over side A is equals to sine B over B. Now that we have all the angles, so the only thing left now is calculating B. But now let's look at a different triangle now and try and work out the sine formula and see if it's going to work for us. A, B, C. This is 10 centimeters. This is 60 degrees. A is 60 degrees. Side AB is 10 centimeters and side AC is 15 centimeters. We want to use trigonometry, or we want to use any way we know how to calculate missing angles and missing sides of triangles. We do not have side BC, we do not have angle B, we do not have angle C. So now what are we going to do? Sine formula. The sine formula requires that we have sine A over A is equals to sine B over B equals to sine C over C. So we'll pick any two here and substitute. Let's look at what we have. We have angle A, but we do not have side A. Okay? And then we have side C. We do not have angle C. We have side B. We do not have angle B. So we cannot complete this equation for this formula for us to be able to solve. We cannot pick any two of these ratios that will work for us to find the missing angles or the missing sides. So what are we going to use now? Let's find another way of solving this one. Let's try if you're given two sides and the angle in between. How are we going to do that? Let's try and cut another line again like we did when we derived the sine formula. Say you're given triangle A, B, C. Remember we now saw cut to our right. So if it's a right angle triangle, you just use sine is equals to opposite of hypotenuse. Cosine is equals to adjacent of hypotenuse. And tangent is equals to opposite of adjacent. Or we use Pythagoras. Pythagoras simply means C squared is equals to B squared plus A squared, which means the hypotenuse, the length of the hypotenuse is squared is equals to the sum of the other angles squared. So we have the other sides squared. If this was A, B, C. So you can have C squared is equals to A squared plus B squared. But this is not a right angle triangle. So now let's see what we can do. Say this is our theta here, which is A. We draw a line here, which is going to give us a right angle, two right angle triangles. And we want to use full lines and full angles. So we can either use triangle angle C and side BC, which is side A, or we can use angle A and side C. That's the only full one. If we cut on this line, on this new line we have here, and let's say this is BF. Let's see how we do it. Now we want to use the cosine formula. The sine formula couldn't work for us. Let's take a short break so we can start over and come back from a break and do the cosine formula.
I can't sit. I can't sit.
Welcome back. You're still watching Home Learning. Today we're doing maths trigonometry. Now we're trying to solve for unknown sides and angles in a triangle that is not right angled. So we cannot use Pythagoras. We cannot use the opposite over adjacent because we do not have the hypotenuse. Now this is a normal a triangle, ABC. We've cut it to find two right angle triangles and try and use the trigonometric ratios that we know and see what we can do. We use the sine formula that side and we realize it cannot work with everything. So now we try to use the cosine formula and see where it's put, what we can get. Now we said that in Pythagoras, if you have a right angle triangle, ABC, if C is the hypotenuse, C squared is equals to A squared plus B squared. So if you divide by C, if I divide by C squared throughout the equation, I'm going to find that 1 is equals to B squared over C squared equals to A squared over C squared. So now, looking at the trigonometric ratios of the right angle triangle, the sine, if this is our theta, the sine of theta, this is B, and this is A. The sine of angle B is equals to the opposite over hypotenuse, which is B over C. And the sine and the cosine of angle B is equals to adjacent over hypotenuse, which is A over C. So if the sine of B is B over C, this is B over C. We said we have 1 is equals to B over C squared plus A over C squared. The cosine is A over C. The sine is B over C, which simply means that 1 is equals to B over C squared, which is equals to our sine, plus A over C squared, which is equals to our cosine. Now we get that 1 is equals to cosine squared theta plus sine squared theta. So to add on what we know, now if you square the cosine of the same angle and add it to the sine of that same angle, you're going to get 1. Any given angle satisfies this condition that if cos squared theta plus sine squared theta is equals to 1. So knowing that, let's go back to our triangle, which we're trying to solve using the cosine formula this time, because the sine formula didn't work. So we'll start the cosine of theta here. we have BF, a new line. And then we have AC is still full. AB is still full. If you cut it, we have AC full, AB full this side. If you cut it, we take the other side, we'll have BC full. Let's use Pythagoras to find BC. BC squared is equals to CF squared plus BF squared. So we say BC squared is equals to BF squared plus CF squared. What is CF? What is BF? When initially our triangle didn't have F. So you're given any triangle with 3 sides and angles. You're given any sides or angles. You won't have F. You will have a full sides but not F. So how do you find this one now? We go back to our triangle. This is BF. This is CF. So now you see that BF is the opposite of angle C. So if BF is the opposite of angle C, now we have A. That means we can use BF. Let's clear our disk now so we can have a clear working space. We say that C squared is equals to A squared plus B squared, right? And then we find that using the Pythagoras formula, we found that 1 is equals to cos squared theta plus sine squared theta when we had a right angled triangle A, B, C. When we said if the sine of angle theta is A over C and the cosine of angle theta is B over C. So we found that if C squared is equals to A squared plus B squared, then 1 is equals to cos squared theta plus sine squared theta. And then now we're trying to find the missing angles of this triangle here. This is A, this is B, this is C. We draw a right angle triangle here. We use Pythagoras to find BC. We say BC squared is equals to BF plus CF or squared. Now, what is BF? We say we take this one here, angle theta. This is side A, this is side B. And the only full size here we have is the hypotenuse. So we're going to say the cosine of angle theta is equals to CF over A, which is the hypotenuse. And our angle theta is angle C. So now CF, which we do not know, we have to substitute CF here. CF is equals to A cos theta, which is C. So CF is A cos C. CF is a fraction of a longer side we are given here. The longer side is B. So which means CF is equals to B minus A cos C. How is the following? We are looking for BC. BC squared is equals to BF squared plus CF squared because it's a right angle triangle. We cut a new line. We cut a new line BF, which you won't find on any given triangle. So now we want to use what you will find in any triangle. So now we have to find BF and find CF. We say BF, we can find BF. We started with CF. CF is the side, it is the adjacent. So if the cosine is equals to adjacent over hypotenuse. So if we say the cosine of C equals to the adjacent CF over A, the hypotenuse. So now we have CF. And CF is a fraction of the longer side A. So we have longer side CF is equals to A minus AF. Sorry, we have it's side B. So we have CF now is equals to B minus A cos C. And then we can substitute CF up here. And then we come to BF. What is BF? BF is this height here. How are we going to find that height? Which ratio can we use to find that height? So we can substitute. We can use, using the same angle here, we have, this is the opposite. We can use the sine, but you see the sine couldn't work for everything. So now we want to use the cosine. What is important here is we want to find, we have found CF, we want to find BF now. BF using the other angle that side, which is this one, angle A. The cosine of angle A is equals to the adjacent over the hypotenuse. Adjacent of angle A is AF. Hypotenuse is B. Sorry, is C. This is angle, this is side C here. This is side B this side. So we have over C, which means AF is equals to C cos A. AF is equals to C cos A. What is AF now? AF is the angle, the fraction that is missing when you subtract BF from B. Let's go back to our triangle and see this is AF. So B minus CF will give you AF. So AF is B minus CF. So AF is equals to B minus CF. So now we have AF, we have CF, we have BF. Let's try and substitute into the main equation now and see what we can get. We say it's BC squared is equals to squared, where BF, where we have BF, which is the opposite of this angle here. So we have the opposite over the hypotenuse, which is C. So BF is equals to C sine A. Now we go back. We have equals to C sine A squared plus, sorry, B sine, let's go back to our angle, sorry. We were working from angle C, so we said BF is the opposite of this angle here, so it's the opposite, sine C over is equals to BF over A. So we have A sine C plus B, the other one we found here, which is B minus A cos C. So we have B minus A cos C squared as well. BC squared is equals to C squared sine C squared plus, when we're squaring a binomial, we know you'll have the first term squared plus twice the sum, twice the product of the first term and the last term. So we have B times cos A times C cos A times 2. So it's minus 2 B C cos A plus cos A squared. So now we have C sine squared plus B squared minus 2BC cos A plus cos C squared cos squared A. Remember that we had sine squared plus cos squared is equals to 1. So if you open the brackets there and collect like terms, you're going to find that BC squared is equals to C squared plus B squared minus 2BC cos A. And BC, side BC is side A, which means A squared is equals to C squared plus B squared minus 2BC cos A. So the angle you are using will be opposite the side you are looking for at all times. So if you are looking for angle B, you're going to have B squared is equals to A squared plus C squared minus 2AC cos angle B. Let's look at some examples so we can work out the cosine formula, where you are given two sides and one angle. For example, we have angle A, triangle ABC with 30 degrees here, 5 centimeters the side and 5 centimeters the side. We are looking for side A. Side A squared is equals to side B squared plus side C squared minus 2BC cos A, which when we substitute here, we have 5 squared plus 5 squared minus 2 times 5 cos A. Another example would be a triangle where you are given that this is 40 degrees, this is 5, this is 7 centimeters, this is A, B, C. So we are looking for side B, which means B squared is equals to A squared plus B squared plus C squared, minus 2AC cos B. Substituting these values, side A is 7, side B is 5, minus 2 times 5 times 7, multiplying the cosine of B, which is 40 degrees. And always remember that your calculator should always be on degree mode. Now we've found angles using the sine formula and sides using the sine formula, which is sine A over side A is equals to sine of angle B over side B equals to sine C over side C. And then we looked also at Pythagoras. We know that the longest angle of a right angle triangle, which we call the hypotenuse, squared is equals to the sum of the other sides squared. And then we still remember SOHCAHTOA, which is sine is equals to opposite over adjacent over hypotenuse, and cosine is adjacent over hypotenuse, and the tangent is the opposite over adjacent for a right angled triangle. So the cosine formula for a 9 right angled triangle would be A squared is equals to B squared plus C squared minus 2BC, multiplying the cosine of the angle A. So if we are looking for an angle, you must have the side opposite that angle. Or if you are looking for a side, you must have an angle opposite that side for the cosine formula. And you need, so which means you need to have an angle and two sides. So you have two sides and the included angle. The angle should be between the two sides you are given. Whereas for the sine formula, you must have at least one angle with an opposite side given. And then you can be given only an angle or only a side, it won't matter. But as long as you have one side with an opposite angle or an angle with an opposite side, you can use the sine formula. For cosine is two sides included angle, whereas for sine, you must have one side with an opposite angle. Then any side or any angle you'd be able to calculate and find all the missing sides and all the missing angles. And then another thing is, when you're calculating the area of a given triangle, the area of a given triangle is half base times height. But it's not always that you can find the height. At times you have to extend the triangle to get the height. An angle like this, triangle like this one, so this would be the height. You're not given the height, you have to first calculate the height before you can find the area. At times, you have a triangle like this one, where you have to extend this line here for you to find the height here. So it's a lot of work. Let's see if we can find the height using the Pythagoras, using trigonometry. We'll say this is the base. We'll say if A, B, C. So side B will be the base, and this is our height. Let's say this is F. What can we do? So you want to find a way, if you are given the angles and the side and the sides of any given triangle, can you be able to calculate the height without the need for you to draw the height and first find the value of the height before you substitute into this formula which says half base times height? So if this is the base, so the only thing that you need would be the height that you don't know. And now you have a right angled triangle. So if you have a right angled triangle, you can use trigonometric ratios to find this height here. Well, if we use cosine, we'd need the adjacent and the hypotenuse. The adjacent is AF. We do not have AF, so it will be more work cutting AF, so we cannot use AF. And we cannot get H, so it's AF and the hypotenuse. But the sine is going to give us H when you use the hypotenuse. So the sine of angle A is equals to the opposite, which is the height we're looking for, over the hypotenuse, which is C, which means the height is C sine A. Let's draw the height from the other side now. If we draw the sine from A, the height from A, so we'll use angle C as our theta. So sine C will be equal to the height over our hypotenuse now is B, which means, and the base now, if this is our height, the base will be A. So the height now will be B sine C. So substituting back into our area, we say area is equals to 1/2 base times height. If we're using theta as our angle, our height would be BF. So if that is our height, our base would be B. So it's half B, and the height we find is C sine A. Whereas on the side our base was A, so it's half A, and the height is B sine C. So given any triangle which is not right angled, you can find its area when you have the angles and the sides. Here the area is half base times height, and the base, the sine is C sine A. So you have 1/2 BC sine A. You have 3 angles in a triangle, you have 3 sides in a triangle. If you are given angle A, that means the sides you're going to use is side B and C. So it's half BC sine A. If you're using sine C, that means the other sides you're going to be using a side A and B. So area is going to be equals to half AC sine B, or half AB sine C, or half AC sine B, half BC sine A. So if it's the angle that is A, that means you're going to use the other sides, B and C. If you're using angle B, that means you're going to use side A and side C. Now let's work on some examples. So we say that the area of a triangle is half BC sine A. So if you're using an angle, then the sides you're going to be used are the other sides, not the one opposite the angle you have. Let's look at some examples. You have a triangle given two sides and an angle. So we're going to have 4, we're going to have 6.3 centimeters, we're going to have 4 centimeters here, and we have 112 here. This is the angle we have. We cannot cut it here and find the half base and half height. So now, because this is the angle we're using, we know that the height must have been cut here so that the angle would be opposite our height. So we can use the sine formula. So we say that its area is equals to half, you substitute two sides sine of an angle. You look at the angle you've been given here. Here we given angle A, angle C. If we give an angle C, that means we're going to use side A, we're going to use side B, which means we have 112 here, which is angle C. That means we're looking for side A is going to be 4, side B is going to be 6.3. So if you're given an angle and the two sides that starts from that angle, then you can find the area of a triangle using the sine formula. I hope you were able to be helped today in advanced trigonometry. It all starts from SOHCAHTOA, which is sine is equals to opposite of adjacent, cosine is opposite of hypotenuse, cosine is adjacent over hypotenuse, and tangent is equals to opposite over adjacent. And then today we worked on triangles which are not right angles, where we cut them and derived the sine formula, the cosine formula, and the area of the triangle. That was all for today. Thank you very much. See you next time, same place. This is still home learning.